11.8 Surface area and volumes of spheres. Essential question: how can you find the surface area and the volume of a sphere? Let's take a look at the vocabulary for spheres. It has some of the same words that we use for circles. One of the words we use is center. There is a center for the sphere. We also use the word radius. There is a radius for a sphere. And we do use the word chord. Chord, endpoint on the sphere, another endpoint on the sphere. The longest chord is the diameter where it goes through the center of the sphere. Great circle will be when you have a plane that intersects. The cross section is a circle, and it's a circle that contains the center of the sphere. If the plane were to intersect in another spot, it would create a circle as well, but this circle would be smaller, wouldn't be as great. Surface area of a sphere is S is equal to 4 pi r squared. Let me give you a model that'll help you remember this. Think of the cover for a baseball. If you were to pull it apart, the area would be about 4 circles. And that's again what the formula is saying, is the surface area is 4 times pi r squared, 4 circles, using the radius of the sphere. Let's go ahead and show you how to find these. Surface area, write out the formula, find the radius, put it in, and then multiply it out. In this case, the surface area is given 12 pi 4 pi r squared. Notice that I went ahead and divided both sides by 4 pi. When this happens, then we have some reducing going on, and I get r squared is equal to 3, and then therefore r is root 3. Here's another problem where I'm asked to find the diameter. I write out the formula, I write down the surface area, 4 pi r squared, go ahead and do some reducing. And when 4 goes into here, it's 5.0625. Take the square root of that, we get 2.25. But remember, the question asks for the diameter. So don't forget to double the length of the radius to get your diameter. Your turn. Stop the screencast and see what you can do. And here are the answers. In number 2, I had to use the circumference formula to help me find the radius. And once I got the radius, I was able to put it into my formula to figure out the surface area of the sphere. Now let's talk about volume of a sphere. And the volume of a sphere is 4/3 pi r cubed. Volume has a cubic idea, so this makes sense that my unit should be in a cubic form. Now here is the reason why it's 4/3 pi r cubed. What we're going to do is we're going to compare two volumes that are exactly the same. We're going to compare a volume of a hemisphere where the radius is r. And we're going to compare it to a cylinder who has some volume taken out, a cone. And this cylinder has a height of r, right here, height of r. From here to here is a height of r. And it can be shown that this area of this circle has the same area as what we call this a washer. A washer is where you have a circle and another circle taken out of it. These two have the same area. They have the same height. So Cavalier's principle says they must have the same volume. So this hemisphere is actually equal to the volume of the cylinder minus the volume of the cone. Now the cylinder is the area of the base, which is a circle, pi r squared, and it does have the same height as the radius, r. And the cone is the same idea, but 1/3. So in the end, it's really just 2/3 pi r cubed. And again, remember, all we found is the hemisphere. So to figure out the whole sphere, you're going to have to times by 2. And taking 2/3 and timesing it by 2 will be 4/3. And let me show you the formula again. So the volume is equal to 4/3 pi r cubed. Let's go ahead and see how we use the formula. Write out the formula, substitute the radius in there, and then you get your answer. Your turn. Stop the screencast and see how to do it. Here's the answer. What I had to do is use the surface area formula to help me find the radius. Once I found the radius, I was able to put it into the volume formula and figure out the volume of the sphere.